week 33.5, week 28 usage. Normally I tell you that the description of the setup at home is in the description below, but this time I'm going to make something a little bit more visual. The reason why I'm doing this is to try and solve some of the phantom drains some gateway and powerwall users are getting along with the SMET2 meters. So the supply running to the house is a 100 amp TNCS supply. Now that fuse has recently been upgraded from an 80 amp to 100 amp, so I know it is a 100 amp supply. And from that 100 amp supply coming into the house, we go to the Powerwall gateway, and the battery is connected to the gateway. And from the gateway, we then go to consumer unit 1. On consumer unit 1, we have our 3 kilowatt peak solar inverter and array. The array is 2 strings of 8 panels. Also on there is the ohme smart charger. That's on the consumer unit number 1 also. And there's a sub main going from consumer unit 1 to consumer unit 2. Now consumer unit 2 does all the heating systems in the house, so that's the hot water system and the my energi Eddi device, which has 2 elements coming off it. Has 2 elements coming off it in the 210 litre water tank. Now the boiler is a 12 kilowatt electric boiler, and there's also a link between the 2 devices to stop basically them working at full power at the same time, so there's a little bit of smartness going on there to stop overloading. So that's the heating systems, and also from consumer unit 1 there is a sub main again which feeds the Vphase unit. Now the Vphase unit is a voltage optimizer that brings the voltage down for everything running off the optimizer down to 220 volts. Now all the other circuits in the house are running through that optimizer, so that goes to consumer unit 3. So we've got 2 lighting circuits and 3 32 amp ring main circuits running off that. And if the optimizer does get overloaded, I think it's rated at around about 20 amps, but if it goes over 20 amps pulled at any simultaneous time, a relay opens up and basically it puts the full voltage from the incoming supply to them circuits to supply it. So if I have the oven on, the toaster on and the kettle on, the relay opens up and basically it gets full power. It's just the limitations of the Vphase unit, but if you want to know more about the Vphase unit, I'll link 2 videos below which goes into some more detail of how it works. I thought I'd also show some detail from the My Energy Watchdog app. I just show 2 watts, 36 watts of phantom drain, which is permanently being pulled from the grid. It's very little on my system, but when I first had the smart meter installed, this was at 200 watts constantly, and I contacted Octopus pretty quickly after it started pulling this 200 watts, and within 24 hours it had stopped and it had come down to these single digit wattage meters. So there is still a bit of phantom drain on there, but it's very little compared with what others are seeing. And this is the data from the Tesla app from exactly the same day, so very little being shown that's being pulled from the grid. So the Tesla app isn't as accurate as what the Watchdog app is. And the Watchdog app gets its data directly from Octopus themselves. Anyway, back to normal. Moving on to Monday, the 6th of July, we had a cost of 3 pence for 5.78 kilowatt hours, which has given us an average cost of 0.58 pence per kilowatt hour. On Tuesday, the 7th of July, we had a cost of 2 pence for 0.17 kilowatt hours, and that's an average cost of 8.87 pence per kilowatt hour. On Wednesday the 8th of July we had a cost of £1.02 for 16.12 kilowatt hours, which is an average cost of 6.32 pence per kilowatt hour. On Thursday the 9th of July we had a cost of 87 pence for 17.06 kilowatt hours, with an average cost of 5.11 pence per kilowatt hour. And on Friday the 10th of July we had a cost of £1.34 for 23.03 kilowatt hours with an average cost of 5.84 pence per kilowatt hour. On Saturday the 11th of July we had a cost of 60 pence for 11.82 kilowatt hours, which is an average cost of 5.04 pence per kilowatt hour. And finally, Sunday the 12th of July we had a cost of 17 pence for 3.02 kilowatt hours, which is an average cost of 5.73 pence per kilowatt hour. That's given us a total cost for the week of £4.05, which is £5.51 including the VAT and the daily charge, and now we're up to £370.03 for since the start of 2020. The average cost for the week from what we've pulled from the grid was 7.1 pence per kilowatt hour. If you include the solar generation in that brought the average cost down to 3 pence per kilowatt hour. The yearly averages are now 5.4 pence from what we pulled from the grid, and 3.2 pence when you include the solar for the averages for the year. And to summarise up until week 28 of 2020, we've now done 2,618 miles charged from home. We've imported 6,208 kilowatt hours from the grid. We've had a solar contribution of 2,362 kilowatt hours, which is totaling 8,570 kilowatt hours altogether. We've had an electricity cost of £370.03. We've had a gas cost of £40.01. So that's a total utility bill up until week 28 of £410.04. We've had 2 FIT payments of £884.19, which has given us a balance of up to week 28 of minus £474.15, including VAT and daily charge. Thanks for watching, and if you can add anything to the phantom draw that others have been experiencing, please add it to the comments section below. And thanks for watching, and please like and subscribe.